I'd like to introduce the last speaker of this session from the CNC Centro Nuovo Comunicazione, Mr. Paolo Miliacchi. The title is Innovative Freight Concept for High-Speed Door-to-Door Delivery, Hyperfreight. Mr. Miliacchi, please.
Thank you. Good morning. So, first of all, I wish to remind that the main author and originator of the concept I will present is Mr. Cavagnaro, former chief director of the high-speed Italian railway program. And my name is Paolo Miliacchi. I work since many years in standardization and research for railways, and I am today at my 8th Wcrr. The motivation at the basis of the concept I will show is the current situation we face in our world, where major concerns are about the environment, the pollution, and the ever-growing energy consumption. And the transportation has a big responsibility on this, and there is a need to shift traffic shares to transport modes which are more environmental friendly, as this diagram of the International Energy Agency shows. In all countries, measures have to be taken in order to achieve the objectives, for example, stated by the Paris Agreement. And in Europe, since 2011, we have a white paper published which states that 30% of road freight should move to other more environmental friendly modes by 2030 and 50% by 2050. Unfortunately, the situation given by existing available data is different. It seems that the railway percentage of market share is not increasing, even struggling to keep at the same level. So we ask how this is happening and what to do. The answer to this question is on 2 points of view. The first one is about trains. We all know that passenger trains faced a very fast and important evolution. So moving to high-speed railways, which required also a specific infrastructure to be built. Vice versa, freight trains also had some evolution, but much slower. And this resulted in an incompatibility of current freight trains with the new high-speed infrastructure. A similar situation is for freight terminals. Also, here we had quite an evolution, but not a really big change. And the result is that loading and unloading operations are rather slow, and the overall commercial speed of freight trains in Europe for international line is just 18 kilometers per hour. So there is a need to solve the situation, and research is being done in the direction of heavier and longer trains, and also shift to rail. The research program in Europe is tackling the issue, but this is for the moment bringing to improvements, not to really disruptive new concepts. We think there is a need to go in the direction of lighter and faster trains, which can really bring to new breakthrough technologies and new business models. Our answer has been named hyperfreight. What is hyperfreight? Is the combination of two technological challenges. First one is high performance trains, which have a normal speed of 250 kilometers per hour and are able to carry even sea containers. Second part of the answer is high performance terminals, and this needs to solve the problem of fast unloading and loading, and also incorporate advanced safety tests. So let's give a more detailed look to these two technological challenges. The high performance trains is made of 2 end units and up to 30 intermediate units if we wish to stay within the limit of 750 meters. And it must be able to travel on high-speed lines, on existing high-speed lines, and is characterized by a distributed traction system where all axles are powered by a set of bogies which are all the same along the train. Due to the weight to be carried, it is very important to control accurately the tractive and repulsion efforts between the vehicles. And the train is compatible with all standard supply systems in Europe, and optionally can host also an energy accumulator in order to store energy, for example when braking, which can be used later for peak power demand. Going a little bit more in detail, we see that the high performance train and the power unit is not a locomotive, because it is not pulling or pushing the train. It is mainly a substation on wheels which distribute energy and command and control to the whole train. Intermediate power unit are the main part of the train where load is stored using a main compartment, 120 cubic meters, and two box compartments which are 25 cubic meters each. It is to be noted that this removable loading floor, you will understand why in a second. The second technological challenge is the high performance terminal, because such a train needs to be matched to a suitable terminal for loading and unloading. Compared to the previous picture of a current terminal, we don't need many tracks. It is enough to have a single track, and in a suitable space between railways and roads, we can easily build this new concept of terminal, where there is a main station for unloading and loading operation, and two smaller stations for preliminary and final operations. Of course, their role is exchangeable according to the train direction. So the train will go through the terminal station, and moving through it will be unloaded, loaded, and then will leave. This minimizes the stopping time of the train in the station, because as aviation teaches, it is very important to use the vehicles and not to keep them steady. So, of course, the terminal includes areas for interfacing the railway system with the road system, and goods are brought to the area, are tested. If the safety test is not successful, they are rejected, and if it is approved, it is stored and prepared for loading. The unloading loading system includes, as I said, a moving floor of the main compartment, where some jacks are envisaged in order to keep it in position while the operation is done. I think we can look at it when the train arrives. It stops in the right position. Then the jacks, as you can see, are risen, and the load can be lowered to the lower load handling level. Then it can be swapped in order to prepare the loading of it, and then it is put in the wagon again. So in parallel, the loading and unloading of the box compartment happens, and in this case we have a shift of the load so that the new load replaces that which arrived, and additional load can be prepared for the next train. So this is an overview of the all unloading, loading main station, and you can see that operation can occur in parallel between the big load or container part and the boxes part. And more loading and unloading unit can be done in parallel, so that the total time of the operation is much shorter than today. Examples of loads are the ISO maritime containers, and for the box compartment, the aircraft containers. But we can store other types of containers, like smaller 20 feet containers, or other loads depending on the needs. And special attention can be that even small trucks or swap bodies can be stored, which can represent the best way to achieve a high-speed door-to-door delivery. Of course, this requires huge international collaboration, and we are in touch with standardization organization, because the interoperability of the system will require suitable standards to be published. And so this shows how this concept can really solve the problem of incompatibility between freight trains and passenger trains, to share the same expensive high-speed infrastructure. And maybe in the future we can see hyperfreight trains running even on the Shinkansen line. Thank you very much.
Thank you, Mr. Uriaki. And are there any questions from the audience?
How far have you progressed with actually delivering this concept and project, and do you have any partners in the sector, or rail freight operators, shippers, to actually get an installation up and going as maybe a prototype?
Sorry, I didn't get the question.
How far have you progressed with this project? I mean, are you at the stage with getting a prototype? Or?
Okay, yes. Well, at the moment, this is just a concept which is carried out by a small group of engineers. But as I said, for sure, to go on, this project will need wider international collaboration, and we are ready to collaborate with organizations which think they wish to go deeper in this concept and hopefully reach also a test level.
Thank you. Any other questions? Yes, please. Mr. Sato.
Thank you for your presentation. I'm from CARS, China Railway Academy of Sciences. You mentioned several international standards, technical committees in your presentation. My question is, are there any international standards related to your project and their development? Are there any?
Of course, as it is a new concept, there are not yet existing standards directly linked to it, but of course we can take advantage of standards for the individual components and parts of the project, because most of it is very much innovative, but of course what is already existing needs to be taken into consideration in the deployment of the concept.
Thank you.
Thank you. Yes, please.
In my mind, if we talk about the containers, that the overseas shipping would be the main place to using the container. So do you think about to combine your idea for railway transportation and the overseas seaports, because from the shipping and they have a lot of container, maybe at the seaports maybe it's a good idea to combine this idea together.
Of course, we tried to show the flexibility of the system, which can accommodate different types of loads, and it is also possible to have sea containers, and of course it is possible to build a terminal in the vicinity of an harbor, and so have sea containers going to trains.
Thank you.
Thank you. 1 minute left, and we can receive a short question. Any other questions? Okay, please.
Yes, Yes, I think your idea is very fabulous, and in Japan we have some difficulty with sharing the track with Shinkansen and the freight train, you know, especially Seikan tunnel between the Honshu and Hokkaido Island. I'd like to ask, I'd like to know that your idea is, can your idea apply to the airtight structure car body? Airtight means our Shinkansen applies airtight structure of the. Is it possible?
Well, I think, as I show, that it is essential for the high-speed freight train to be a closed train, cannot be an open train like today's freight trains. I don't know if it is necessary to reach the level of airtight. Maybe not, because loads are not so delicate as people. But for sure it must be closed, as I've shown, and the box compartments have doors, while the main compartment has a moving floor, and this is helpful to speed up loading and unloading, which is one of the main points for having a good return from investment.
Thank you very much. Thank you very much.
Thank you again for your presentation, Mr. Miyaki.
Thank you.
Okay, all presentation in this session were finished. In closing, I'd like to thank the speakers for the contribution and also thank the audience for many comments and for joining the active discussions. Thank you.